This is Math 139. We're looking at section 4.4. We've been working with rational functions, or algebraic fractions, and in this section we're going to take a look at what their graphs look like. I'm going to start with the simplest possible rational function, just the algebraic fraction 1 over x. I've got some x values here, and we'll take a look at what the y values, 1 over x, would look like. So if x is 4, then 1/4 would be the y value. And 3 would become 1/3. 2 would become 1/2. If I substitute in x equals 1, 1 divided by 1 is still 1. And 1 over 1/2, think multiply by the reciprocal, we get 2. 1 divided by 1/4 is 4. Notice that 1 divided by 0 is undefined. We cannot have 0 on the bottom of a fraction. Down here we have all the same inputs except negative. So we'll just get -4, -2, -1, -1/2, -1/3, and -1/4. Let's plot these points. By the way, notice the scale. Every tick mark is actually 1/2, so be careful with that. 4 1/4, 3 1/3, there's just a little under 1/2, 2 1/2, 1 1, and so on. Like so. What we're seeing here are two distinct pieces of graph. We know that when x is 0, there can be no place on this line where it has a y value, because when x is 0, there is no y value. So I'm going to say on the right-hand side of the y-axis, we have a shape that kind of looks like this. Seems to be getting closer and closer to the y-axis going up here, and closer to the x-axis, coming out that way. And then a very similar shape down here in the third quadrant for the negative inputs. The features on this graph that I'd like you to particularly notice are, first of all, it has two asymptotes. One is vertical, the other is horizontal. The vertical asymptote is this y-axis. We know the graph will never touch it or cross it because x can't be equal to 0. So the y-axis, or x equals 0, is the vertical asymptote. There's also a horizontal asymptote, which is the x-axis. We can see the graph getting closer and closer on both the positive and negative sides. So that would be y equals 0, the x-axis. As far as intercepts, there are none. This graph does not cross either the x or the y-axis. The domain. X cannot be 0. We saw it in the table. We can also see on the graph. When x is 0, there's no y value. And as far as the range, we never get the y value of 0. We never have a point that's right on the x-axis. So y is not equal to 0 for the range. If this is our basic graph, we can use the idea of shifting graphs, left, right, up, down, and so on, to do transformations of this basic graph. And when I transform rational graphs, I usually start by transforming my asymptotes. The graph itself is built right around the asymptotes. So let's try that. In our first example, we have 1 over x plus 2 minus 3. The transformations I'm seeing here are to the left 2 and also down 3. So I'm going to take my origin, which was where my asymptotes originally met, and I'm going to shift that to the left 2 and down 3. I'm now going to draw new asymptotes vertically through my point and also horizontally through my point. So my new vertical asymptote, this line here, is x equals -2. And my new horizontal asymptote, that line, would be y equals -3. All right, I'm just going to sketch in this basic shape surrounding my asymptotes. Being really careful to not touch or cross either the horizontal or vertical one. And there's my graph. The domain, x is never equal to -2. And the range, y is never equal to -3. So once you know the vertical and horizontal asymptotes, they basically give you the domain and range as well. All right, what about this other example? We've got our function as -1 over x minus 1. Because of the multiplier of a -1 here, I know that this is upside down or reflected across the x-axis. This also gives me to the right 1. So again, I'm going to take the point where the asymptotes cross, which was originally at the origin, and I'm just going to move it to the right 1. I'll draw both a vertical and a horizontal asymptote through that point. All right, normally I've got my curve here in the upper right quadrant. If I were to flip that upside down, it would be in the lower right quadrant. Like so. And then this one, again, flipping that upside down would go into the upper left. And that's as accurate as we need to be. Again, if we wanted a super accurate graph, we could always do it on a calculator or computer. My vertical asymptote right here is at an x value of 1. And my horizontal didn't move. It's still at y equals 0. So for the domain, x values never equal 1. And the range, y values never equal 0. So that's how you can graph by shifting our basic graph for a rational function. We'll take a look at some slightly more involved rational graphs in the next video.